Hello, students. The question is 1.69 of the book Erodov. The question say that a bar of the mass m resting on a smooth horizontal plane starts moving due to the force F equal to mg by 3 of constant magnitude. In the force, in the process of its rectilinear motion, the angle alpha between the direction of this force and the horizontal varies h alpha equal to the as, where a is constant and s is the distance traveled by the bar from its initial position. Find the velocity of the bar as a function of the angle alpha. So in the question, we need to find the velocity as a function of the alpha. So first of all, we will draw the free body diagram. The step one question is given a bar of the mass, and this is the bar, suppose, and a smooth surface. This surface is smooth, that means there is no frictions, and a force mg by 3. This is force applied at angle alpha, and the value of the alpha is given the as, where a is constant and s is distance traveled by the bar. Okay, so find the velocity. So first of all, we will do the free diagram. The component of the mg by 3, one component is the horizontal component, that will be the mg by 3 cos as, and another component is vertical, that is mg by 3 sin as. From the surface where the bar is rest, in normal direction will act in the normal direction, and the mass of this body will be downward, mg. Okay, there is no motion in the vertical direction. There is no motion. So step second, take equilibrium. Take equilibrium in y direction, because the bar is travel only x direction. So bar is travel only in the x direction, and this is the y direction. No motion in the y direction. That means no, net force in the y direction will be 0. So net force in the y direction will be the 0. Summation of the Fy will be 0. Okay. So upward force is, one is mg by 3 sin as, and also the n, and also act in the upward direction, is equal to the downward force is mg. So from, if this equation is required, we will use it also. Okay. Now step number 3. In the step 3, we will use the horizontal equations. So here we see that the only mg by 3 cos as is force acting on the body in the x direction. So mg by 3 cos as is equal to the mass into the acceleration. Is equal to the mass into the acceleration. Okay. So we need to calculate the velocity. So we will use here m v dv divided by the ds, because value of the acceleration is given by also dv upon the dt. When the some equation given in the form of the time variable, then we use the term a equal to dv upon dt. But here the term mg by 3 cos as in the form of the displacement. So here we are going to use a equal to the v dv upon the ds, and this is mg by 3 cos as. Further, we will simplifying this equation. So m and n cancel out from both sides. So we can write it m v dv and the g by 3 cos as and ds. Here you can use the some mathematically adjustment of the equation. So here we can write finally v dv equal to g by 3 cos as ds. You can solve it. You will get the written equation. Now integrating both sides. So initially, in the question is given that a bar is resting. That means the initial velocity of the bar will be zero, and final velocity is supposed to be v. So initially no displacement, so final displacement become s. Okay, so we can write v square by 2, 0 to v. Okay, from here g by 3 taking the common, and cos as. The cos as in a integration, the integration cos ax will be the sine as divided by the a. Okay, 0 to s. Now substituting the value, so upper limit minus lower limit becomes 0 to g by 3 times a, and upper limit of the s, so this becomes the sine as, and then the lower limit putting the 0, this is going to come the 0. Okay, so v square is equal to the multiplying 2 in the right side, 2 by 3a, and this is the g, and sine as we can write in the form the alpha also, because alpha equal to the as already given in the question. So further simplification, we will get the v equal to the root over 2g by 3a sine alpha. This is the velocity. This is the velocity. Here, step 2 equation uh, is not used in the complete process of the solution of this given question. So in anywhere, if you use, if you need find the velocity or any other parameters when the bar leave the contact from the horizontal surface. In this case, we will use the equation 1. When the particle, your bar, leave the horizontal surface, then the normal direction became 0. In this case, the equation will be the valuable equation. But in this solution, step 2 is not used anywhere. Okay, so this is the velocity, v equal to the root over 2g by 3a sin alpha. Thank you for watching the video.